it up a notch.
G'day teachers and welcome to Tech It Up a Notch. I'm Rach, your curriculum guide, here to help you connect tech to powerful learning.
And I'm Claire, your tech guru, ready to demystify the digital world for your classroom. Okay, what are we featuring today? I think you found something because we're both on a lot of Facebook pages for teachers, and we often are commenting and giving advice on there.
Yeah, or tagging each other when we see something relevant.
But I think you found one that stood out to you, Rach. Is that right?
It did. And this person says,
how do you use Scratch in your Year 5 and 6 classroom? Students are disengaged with Grok, Academy, and Code.org. They're asking for Scratch and only Scratch.
So, what were you thinking when you saw that?
I thought there's nothing wrong. Well, there could be some things that you might want to consider when using Scratch, but if the kids are asking for Scratch,
use it.
Scratch.
Yeah. Oh, I love Scratch, honestly.
It's sort of like the OG coding platforms, I feel. Maybe it's not actually, but it's been around for such a long time.
Yeah.
And I think that helps. So if someone's feeling a little bit nervous, but, I've heard of Scratch, they might be a little bit more inclined to give our teachers give something a go.
Yeah. Well, we'll explain what it is. So Scratch is a free block-based visual programming language and online community, and it's mainly designed for children roughly around ages 8 to 16. You could probably go a little lower. I probably wouldn't go with stage 1. Stage 2 at the earliest, so 8 is about right, to 16 roughly. But it can be used by people of all ages, teachers even, to learn the fundamentals of coding. So how it works is users can create an interactive story, a game, or an animation. They just drag and snap together coloured code blocks, which makes learning the logic of programming easy without worrying about understanding like Python coding or all of that kind of stuff. And that's why I love introducing block coding with students for that reason. It shows them the power of coding, and that makes them think about, oh, wow, like every game that I play, everything that I use, someone has coded all of this before, and it's a lot of work. And just having even a block is a lot of coding in itself if you view the coding behind it. But it's very cool, and it's a really lovely way to introduce it and give them some success with creating something themselves digitally, in a cool new way, which we always are all for. So to find it, it's a website. It's scratch.mit.edu, and that's where you can create projects, and you can even share them with the large global community. So when I do this with students, I get them to sign in and create because often these projects, when they start getting into them, there's a lot of steps involved and you can't get it done in one session.
No.
They have to be able to log in and save their work. Otherwise, and I've had many a time, lots of tears and frustration when things haven't saved.
And you know what I do that might be helpful to talk about? Because when you sign up for Scratch as a student, it says don't use your real name, don't give information. So it's a great little reminder for kids about
or your real birthday or anything like that.
Cybersecurity. But I then ask them to use a formula. So they use their initials.
So they don't forget.
Because they do forget. They sign up and they forget what they've used. So we use their initials, and then they can have whatever, like mine's pineapple ribbon or something. So I just say, pick 2 things. I don't mind what. And then, but it's the initials so that when I'm in the back end, because, on that very first day, they can join your class, you can see all the students' accounts. But when they forget their password, you can go back in and reset it if you know what their account is, and their initials help with that. So
that's a good teaching tip.
That's my top.
Yeah, for sure. So basically, once you go to the website, and for my students, when I start using it, rather than jump straight in, I like to do a couple of lessons on the Hour of Code website first. I think I've mentioned it before, the dance party game. And it's such a really lovely way to introduce block coding because it's simple, step by step. And it progresses in difficulty. What's going on today? And it gives you hints along the way. And then that builds their confidence with block coding, I feel, rather than diving straight into Scratch without that step-by-step help is a bit overwhelming, I find. A lot of kids just like, no, it's too hard, I can't do it. So this builds the interest in block coding, gives them some success first, and then they want to try it. So I find I do a lesson on the dance party, and then the next lesson we try the Minecraft ones on the Hour of Code.
Oh, I haven't done those.
They're a little bit harder, and you've really got to think about to get the character to move in a certain directions to different points. You've really got to think, and it's actually much more challenging, but you get little certificates as you progress, and then the next lesson is Scratch. And I love to start by, there's a little video when you first sign in, and I always start with that. Do you?
I do start with that as well.
Yeah, and it's a very simple video and goes for about a minute and just shows all the different things that Scratch can do, and it builds the excitement, builds the interest.
It does.
Yes, and then some kids just want to dive straight in if they're a bit more confident. But on the tutorials page, there's so many videos there. Then I just say pick one of those, watch it, and see if you can try and do it.
Yep.
And a lot of them, like the Make It Fly one. There's so many.
I think there's one, Animate a Name.
Yes,
that's one that I often
a simple
start
one.
with.
Yes, that's a good one too. Creating animations that talk, a chase game, the Pong game. A lot of them want that, but it's hard.
I've done that with Gifted and Talented group. And it took us a couple of weeks, and those kids were pretty focused. They did some really interesting variations on the theme and stuff, but the basic coding behind it still was. There was a lot there.
Oh, yeah. It's a really good one if you can get it. And some kids just get this stuff and it's speaking their language literally and they fly. Yep. But that's a good one for a Gifted and Talented. But yeah, the name one's one I always suggest if they're not sure.
Yep.
So that's a really nice way to start with it. And then after that initial sort of play lesson, introduce the project that you want them to try and do and how they're going to use Scratch to achieve that.
Yep.
In the past, I've used it and it links beautifully with the Makey Makey, and we've covered that.
I've used it heaps.
Yeah, how have you used it with it?
Well, lots of game controllers. That sort of.
Yes.
I think you've done the same sort of thing. Interactive, be it a poster or a Christmas card or whatever it is,
nice.
Where you want a thing in the world to be able to talk. So pressing little buttons.
Yes.
And then connecting the Makey Makey using the Scratch to program whatever I want it to say.
Yeah. I've done it like that too. And also with musical instruments, which was so cool. I think I mentioned this in our Makey Makey episode where kids literally were strumming chords on the guitar and recording it.
Yep.
Yeah. But what's really cool in Scratch, there's a My Blocks section. Down the bottom, you press the little plus element in the bottom left-hand corner. That's purple. And then there's all these extra blocks you can add, and there's a whole Makey Makey one that you can do. So when you've connected it to the Makey Makey, you can program your sprite to move when you press the left button, it does
on
this.
Your Makey Makey built whatever it might be.
Yeah, with the foil.
And then I know it connects to Microbit as well.
Yes, it does. There's a Microbit one too.
It's handy, and I'm just having a little look through.
Lego Mindstorms, Lego Boost, We do. I didn't even know that.
Interesting. I wonder now that Lego seems to be getting
they've got their own kind of.
They do have their own software, but then the original one.
Yeah, because that's We Do, which is now not, the app's gone too. So interesting. There might be use for the old We Do kits.
Yeah, because I'd err on the side of just keep them for a little bit and see if anyone out there has We Do kits.
Yeah, I know. I don't chuck them out.
Don't chuck them out just yet, because we feel like someone will come to the party with good software.
Yeah, for sure. So other ways I've used it, video games, sport games, dance boards, dance pad games, instruments, things like that. But also what's really cool is if the students are kind of stuck, they want to code a particular thing in the game they're making or the project they're doing. And sometimes they ask me stuff and I'm like, I have no idea, mate. I'm sorry. Yeah. So there's a really cool explore section, and anyone who's made something in Scratch can share it to the community and you can have a look. And what I love is particularly when I did even the dance board game, that's a hard thing to try and code. Or a lot of boys wanted to do the goal kicking game for soccer, and you can look for ones that are already there, and you press the button that says C inside it, and you can see the code that they use to make it, which is really cool. And some kids go, but that's cheating, and I'm like, well, it isn't. Like I said, I wouldn't know how to do it if I didn't have that to help me. But then you've got that there as a guide, and I don't want you to copy that exactly, but at least it gives you an idea of, this is how I do that function I was wanting to do.
And it's not cheating at all if you come back to the syllabus. If you're looking, I'm talking Australian curriculum, years 3 to 4, and they're looking to follow and create algorithms.
Oh, there you go. That's
follow
it.
That, we're in the age of explicit teaching, and if you're looking at an example and using that to learn, there is no cheating in that. So,
Yeah, how good.
Yeah.
So a couple of years ago with my Year 4 class, the project that we did for our solar system unit was I wanted them to create in Scratch a way of sharing their understanding of the solar system, the planets, and the relationship between the Earth and the Sun.
Yep.
So they had to try and get the Earth to orbit around the sprite of the Sun. And it was actually like, and then they found all this stuff that I didn't even know you could find where it tracks the years and the days in the corner. You can click on it and it tells you facts. And the couple of boys were so good at it. And this beautiful boy in my class, very quiet, but he could do it.
Yeah.
And then all these kids going, oh, and I shared his as an example.
Yep.
And then everyone's going, Miss, how do I do it like with the orbit? I said,
ask him.
Yeah. And then so in the end, I just said to him, oh, buddy, do you want to do a little masterclass and get everyone to come and look in? Because I said, I don't know how to do it, but I'd love for you. And it was so good for his confidence. And he looked like he was wanting to die. But then but then he did it. He held his own.
Yep.
It was one of those most beautiful moments I'll never forget. And I think I wrote it in his report comment how that was so good for him. And it was so good.
Oh,
so
I feel a bit teary hearing
I know. I love stuff like
that. When our busy curriculum and there's such a focus on literacy and numeracy, which is totally understandable, but this area in particular, your digital technologies, gets forgotten. And it's not about learning from an app. It's about creating and doing and learning how it all works. And, that little kid wouldn't have had that opportunity.
Yeah, and yes, it's out of a lot of teachers' comfort zones, but with someone leading the way and demonstrating and seeing what it's bringing the students, and parents are noticing it because we're sharing it on Seesaw and saying to me, this is so good. I didn't know my child could do things like that. It's been pretty awesome. So,
like to the teachers, you don't have to go to the extent of integrating it in with another thing and making your son go round.
Nah.
To meet your curriculum outcomes for primary, I'm talking year 3 to 6 is sort of where Scratch is really nicely sat. And you could just do the tutorials and let the kids have a go. It doesn't have to be complicated.
No.
You don't have to understand it completely. You can learn along with them by following the tutorials.
Yeah.
So,
well, the first time I got introduced to it was our good mate Chris, and he came to our school and they were reinventing, their space unit, I think it was. And they came up with the idea of creating a sprite that's going to explore Mars. So the sprite, they had to make it and shared facts about Mars and things like that. That was sort of before I had that expertise built myself.
Yep.
But that was how I learnt along with the kids. I was only 2 days a week back then. And
I can't remember when I feel like
it was a long time ago.
I can't remember when I first started. When you just stumble across things and then you have a go and
But what's good about Scratch is it's free.
That's the biggest positive.
Yes, and it's just web-based, so you can access it from Chromebook, iPad, whatever you're using. There's also an app, Scratch Junior. Have you ever used it?
A little bit.
Yeah, it's really good for the younger ones, but obviously the students had before when I taught Year 4 a couple of years ago, and when we were doing the unit on convicts, these girls said, oh, can I make something on Scratch to share my understanding? I'm like, go for it. What she made was awesome.
On Scratch Junior?
Yes, and it looked like a hand drawing to showing what happened when the boat came, and then, and it's very user-friendly. It's like coloured blocks, but it's not written. It's like on
pictures
the
and
the Sphero Indie, that very similar kind of image rather than words on a block.
I have tinkered with it, but I haven't taught a unit or anything with it to talk about it. So maybe that's something we could have as a future.
Yeah, definitely. So we could totally. And it's like it's very a creative way for digital storytelling, I reckon, for sure.
Let's finish the pros. Right? We said a lot of good things about it because it's good and it's accessible. If you don't have robots in your classroom or you just don't have
you've got something
physical tools, you've got something that you're going to be able to use when you use Scratch. But I know that we talked about it in, I think, the Makey episode, that some people aren't allowed to use it in their systems.
Yeah.
Because of that.
I remember that. We had that conversation last year.
And which is unfortunate if you're in that boat. And there was an alternative, and was it called... I can't remember what it was called. There was an alternative that used Scratch, but it was a different way of accessing it. So it didn't have all of that background stuff. I never used it because I just went straight to Scratch. But when I went looking for it for this, it had been discontinued. And it's been replaced with this.
Oh, I know what you're talking about. CS First.
Yes.
Yeah, so Google CS First.
Yes, it was by Google.
Yes, so that was, that really amazing. Google had created their own coding program.
Yes.
It's very similar with lessons inbuilt in the classroom format. Yeah, I never got to use it with students, but I had a play and I saw a few really great sessions at EduTech
and I think
on
it was just Scratch. Like when you actually looked at it.
Yeah. But you're right, like that got closed, that shut down this year.
Yes. So its replacement has just come online.
Yeah.
Experience CS by Raspberry Pi Foundation. Google supports it. It includes Scratch-based units in a more structured environment. So if you've
got an alternative.
Yeah, if you're not able to use Scratch directly, you might be able to use it through there.
Yeah.
I haven't played with it a lot though because it literally has just come out.
Yes, it has. Yeah. But if you want to find out more, there's an experience-cs.org website about it. But so the pros, I would definitely say Scratch is engaging, a wonderful visual programming environment, great for introducing coding. It definitely supports creativity, problem solving, computational thinking, definitely works well across STEM, literacy, arts, digital technologies.
You know what else I think is a positive? A lot of our digital tech stuff is group-based because you have a limited amount of equipment.
Yeah.
Whereas because everyone can access this and it's free and you've got your account happening, sometimes it's just nice to have a go by yourself when you're working stuff out.
And because the students can log in and they've created their own account, a lot of them, because you don't get much done in a lesson. It's by the time we introduce what we're talking about, they go to their desks, they play, they're working, and then they have to pack up. You very rarely get more than about 30, 40 minutes. So a lot of the time, the more successful students are going on at home and kept going with it.
Too.
Yeah, because they're just so into it. But I guess one of the cons I would say then is that security risk. Look, because there is that online forum of where you can share projects and things, there is a chat feature, and I wasn't aware of it until our dear friend Lisa mentioned it to us, and as a thing to be more cautious about when recommending Scratch for schools. So, but at least you can do it in a safe way. But if you are limiting it to just use at school, then that would alleviate that issue, I feel. Because
but how do you stop them from using it at home?
Well, that you can't. Yeah, that's right. But that's what I mean. Like if they're only using it at school, then they wouldn't have time to go on that kind of feature.
It's not like it's really overtly a chat function. And it's more about, I don't think there's like a chat thing in there. I haven't come across one. Isn't it that
apparently
they can chat?
Or you can comment on the ones that people make and stuff.
Let's have a look.
And then, but some of the games that people create could be inappropriate as well.
Well, that's the thing. But my goodness, the amount of kids on Roblox.
Yeah, see?
Yes.
Yes, so that's the issue.
So my feeling though is with the ability to comment on games rather than chat as, more classically if we're thinking of a chat thing, but you can read comments on a Google review. You can read comments on a YouTube video.
Yeah.
So they're already exposed to that in lots of other ways. I do think with Scratch, benefit outweighs the risk.
Yeah, for sure. All right. So curriculum guru, how could we align Scratch to the Australian curriculum?
All right. Well, what I thought I would talk about today is specifically the digital technologies outcomes, because often we talk about how we can integrate, but there's things in our curriculum that get forgotten. A good example is dance. Lots of people teach dance
tell me about it.
as part of PDH. But they don't teach it as a creative art in terms of understanding choreography and appreciating art forms. And
telling stories through dance.
That's right. So I think digital technologies is just like that. I think we've mentioned it before. Kids are using a Chromebook, so I can tick digital technologies outcomes off, and that is not the case. So if you are looking at your digital technologies across 3 to 6, I'm talking about, you're specifically looking at using a visual programming language like Scratch, or there are many others. We've discussed lots of them in our podcasts now. For our years 3 to 4, they're just looking at how they can follow and describe, particularly around the skills of branching and iteration. So branching being that they have a decision somewhere in their algorithm, and iteration that things might be repeated or looped within that algorithm.
Yeah.
So where you might see this is in your if-then programming blocks or if-else, and then using something like a loop or a forever loop or a repeat until will sort of hit those parts
and a lot
of the
them
outcome.
do like exploring with those features, don't they?
They do.
Yeah.
Yep, when they move up into years 5 and 6, then they start designing the algorithms themselves. So before, when we're talking about it's not cheating to be looking at the tutorials, you are just hitting that outcome. Hopefully from year 3 and 4, they'll have that bit of background knowledge, and then they can launch in year 5 and 6 and come up with their own. Of course, our 3s and 4s might do that too. That's okay. Then when they come up into year 5 and 6, they'll be designing those algorithms using more complex branching and iteration and implementing them as visual programs, including variables. So a variable might include if it's storing a player's guess or a number. Yeah, so variables are like having code buckets to store a number of
And there's
things.
so much maths in this.
My goodness, yes.
Isn't there?
And it links directly back to maths. So in mathematics, they're asked to create algorithms involving a sequence of steps and decisions and digital tools to experiment with factors, multiples, divisibility, identify, interpret, and describe emerging patterns. And so often when you're doing this coding, you'll be using a flowchart to plan what you're going to do, particularly with branching and things like that. A flowchart is a really useful tool. So you might go back to our Google Draw episode. Think about how they could use a tool like that, or Canva, which might be coming up. So an algorithm, you can plan it on paper in your flowchart. You're hitting some of those mathematics areas there, as well as learning in digital technologies.
Love
so,
that.
yeah, I think not all ways of teaching with robotics, you know, say if we went back to the Indy cars and they get there and they turn right, you're not really exploring some of the language around creating algorithms that's asked for in the syllabus.
Yes.
But when you're using these blocks in Scratch, you are able to do that more easily.
It's a lot of steps and a lot of thinking.
Yeah.
And it hits a lot of outcomes for
and
sure.
Actual knowledge of how these things work. And I think that's where our teachers avoid it.
Yeah.
Because just like
they're intimidated.
just like choreographing a dance. You know, I don't think
I love that comparison.
it's just like it, because if you create a dance or create a code, it's just the same.
Yeah.
It's a sequence of steps that lead to an outcome at the end.
So we're finishing off. So basically, I think differentiation for Scratch, you'd only really use it for learners from your stage 2 and up, I would assume.
Yeah, I would be reluctant to put someone who was struggling on Scratch Junior, because
100%.
Everyone's going to know you're on that one.
Yes.
I think that it's more about pitching it lower, but giving those tutorials and those opportunities to kids who are flying with it to sort of go off on their own, because it is a little bit more of a individual pursuit in that way.
Yeah. And I found, some kids find it really hard to create something literally from scratch on these things, so to speak. But I just sort of would let them, whatever they were trying to create, use that explore function, find one that's already doing it, get some ideas from that to help them, and just do what they can.
You know what I think too? The kids who are having trouble with it spend all of their time making sprites.
Yes, and finding backgrounds and finding images, because like I remember some kids like, oh, I really want like this whatever sprite, and I'm like, oh, stupid me said, oh, you can upload your own, and so then the whole lesson's gone because they're too busy doing stuff like that.
Yeah.
But then that just shows you that yes, they're interested in it, but they're not too keen on making it perfect if that's all they're worrying about. So that in itself is telling you where they're at, I guess. So
and I've put up code too. Like I'll make, if I want to
so they know I've done that
say,
too.
Like, here's my code, and I just leave it on the screen.
Yes.
So they can refer back to
I've done that too with Sphero as well. Like I had to make particular code for I forget what it was now, like when we're doing the Mars rover. Oh no, to get it to orbit around linking with space, and a lot of it found that tricky, so I had it up on the screen, a screenshot of it. Look, if you've never tried Scratch before, definitely embrace it and give it a go. It's well worth it. And hopefully what we've explained, how we introduce it, is enough for you to feel comfortable enough to give it a go to start with. And honestly, with everything like we shared, the students end up teaching you stuff on it. And if you liked our episode, share our podcast. You can listen to us wherever you find your podcasts. We've got our website, takeitupanoch.com.au, and we're on Facebook, Instagram, and TikTok as well. We are very excited. We had someone reach out and ask a question for us directly on Instagram recently. So please continue to do that. And thank you, Louise, for sending us that. And we have plans to do that in a couple of episodes' time for sure. But so we hope that you enjoyed this episode. And don't forget to
take it up a notch
with Scratch. Bye.
Take it up a notch.
Internet was only fairly new.
We did a lot on like. We're so old.
And look at us. We're
We're
experts.
still so beautiful.
So what were we talking about again?
I don't know.